I would probably start by going to the Zephyr documentation, right? And that's so docs.zephyrproject.org. And from there, following the getting started guide, setting up my environment. So basically, I mean, Linux is kind of recommended. The Windows, like WSL on Windows, is not too bad, as in, like, that's actually what I'm going to use today. So it's definitely not bad. You can use the Mac as well. And if you go through all the setup instructions, basically, you will end up installing what we call the Zephyr SDK, which effectively brings you and already provisions pretty much once and for all the tool chains like the ARM GCC and like Xtensa GCC for ESP32 and like all those tools for being able to actually build code. And it's also going to provision like Zephyr itself, like the source code of Zephyr, the source code of all the code samples. And then one thing that this getting started eventually instructs you to do is to run like build your own existing sample application targeting your own existing board. And that's what I'm going to do right now. So you can use whatever IDE you want, or no IDE at all, by the way, or like depends. I don't know if you call Vim or Emacs no IDE, but the thing is with West, usually like you can actually in terms of compilation, you really don't have or don't need an IDE because it's really going to be just literally one line. So let's see. So yeah, I have the entire Zephyr source code in my mounted in my environment. Again, I'm running on Windows, but WSL, so effectively Linux within Windows. And I want to start with what? Running a Hello World, maybe. I think I have it here. So using West, the West meta tool, as we call it, you can build for a given board, targeting like a given board, a given piece of code. And in my case, I want to run a Hello World. The Hello World is really like, that's really all there is to it. And again, back to my sort of what I was saying about like having like needing to bootstrap all the peripherals, etc. You don't see any of that here because it's effectively all taken care of by Zephyr, and you have code that's, I guess, even simpler than the init and loop in Arduino. And so if I were to build this code, which I guess I had earlier, so that's why it's so fast, I effectively built, and I'm targeting a simulator. So I'm actually going to run Zephyr on my machine. And I mean, that's the Hello World. That's maybe not that impressive. But the thing is, I have another device attached to my machine, which is an ESP32 M5 stack device. If I am to build the same app, the same Hello World for it, let's see, I need to, and I will be bringing my camera. Let's see. All right. Yeah, this guy right here. So it's still building. Let's see, linking, building. So I mean, I'm putting it on the screen, but we won't actually see much because the Hello World shouldn't be doing a lot. But let's see. This time around, I'm gonna actually flash the application, and that's also quite nice. Like, because I really don't need, and I think I actually need to turn it on. Maybe let's see. Yeah, I think it's just not turned on. Oh, interesting. Okay, let me just double check one thing. Where is it? I think I turned it off the wrong way. It's okay because we can actually do a lot with the with just simulator if we need to. Let's see, auto attach. And that's one of the things where actually the the WSL stuff can be sometimes a bit painful. But yeah, no, it should be there. Oh yeah, now it is, I think. Yes. Not sure what happened. So flashing, and I mean, nothing's happening visually. That's kind of expected, but I can easily connect to the serial output because that's what, I mean, for Hello World. Let's see, there it is. Same code as earlier, except that this time it says Hello World from the actual device. That's nice. Let's see. I think, yeah, we have an LED right here, which is essentially doing nothing. Yeah, thanks for zooming. That's helpful. So going back to the code, this time we're going to build not the Hello World. If we show my screen again, we're going to build Blinky. So same target, except that this time I want to build the Blinky sample. And I mean, this is highly unimpressive to some extent, but what is impressive, I think, is that I can really jump like from one target to the other. And Blinky, by the way, I should show the code because there will be it will be interesting to dig into how it works. But let's see. So finishing up with the build, and then we're going to have a quick look at the code and a quick look also at the kconfig thingy that I was mentioning. So let's see. I need to flash now. Now it works much better than. And let's see. The LED should start blinking. Yeah, there we go. LED is blinking every second. So okay, let's go back to the screen because the code. I mean, obviously we don't have a lot of time to dive into the code, but I want to give you a sense of like what's the whole device tree thingy, why it's actually really powerful and interesting. What my application is doing, again, it's a main, right? Like it's not the Arduino loop. It's really like just a main, and I do whatever I want, which effectively is pretty much a loop. I loop forever, and I want to toggle a GPIO pin every second. And this particular pin is something like I'm not hard coding GPIO pin numbers like I would in Arduino, or like the I think like D13 off the top of my head, right? Which is usually the sort of like digital pin 13 for Arduino. No, I'm asking the Zephyr system for a reference to LED 0, which depending on the what device I'm targeting might maybe not exist. It could be the case that the device doesn't have an LED, but if it does, I'm certain that I'm going to be able to toggle it and like to manipulate it as a GPIO. And if I go to my M5 Stack Core 2 device tree definition, so it's a mouthful and maybe as a sort of like as part of this getting started, you might find that there is a lot in there. But the thing is, it's already been done for you, right? Like, I mean, the M5 Stack Core 2, if you have one, then you're not going to have to write the device tree. It already exists. And one thing that that's already there is the definition of what LED 0 should be, which in the case of this particular device is the LED is effectively not directly wired to the SoC. It's effectively wired to another device, another peripheral, like in the M5 Stack Core 2, there is actually a power manager, a PMIC, right? Like a power manager IC, power management IC. And that's this particular device that is effectively like it's through this device, through this PMIC that I am controlling the LED. And so, but I don't care. Like as an application developer, I want to use an M5 Stack Core 2. It's already supported in Zephyr. The only thing I need to know is that it has an LED 0. Now, if I were to create my own PCB again, and or I would want LED 0 to be something else than the one that's like sort of by default used in the M5 Stack Core 2, then I would be sort of tweaking the device tree, right? Like maybe I'm at my LED 0. This is an LED that I want to actually manually connect to one of the GPIO ports of the device, then I would be changing this. But that's that's kind of the idea.